we will go through some of the test standards that was told in the earlier session, like test standards is enough for a tester or a testing team in order to have the test plan, specification, procedure. So we'll go through what is the test plan, what is the test standard. Then we will try to apply what are the standards we are going to use with an example. And to recap some of the session inputs from the last class, we went through the specification, example, test case, how to write, what is the format, what are the contents of test cases, and how it is designed. So what are the steps that is needed, etc. Similarly, test procedure also we had discussed. Test procedure should be 100% covering the test case. So we also went through the test procedure example. Which identifies the grouping of the test cases. Test cases already we have identified in the test specification, and the test grouping is already done. With test procedure, what we do is we will lay out the practical steps of the test cases, which we have laid out in the test case document. So test procedure by itself is an independent document, which has mentioning of the test environment and mapping to the test environment with each of the procedures. So we will have test procedure definition. In the end, we will identify the various tools and setup and test bench, whatever it is. So we told that there are two types. One is automated, other one is the manual type. Both are similar in terms of the tools and the rest stuff, except that in manual testing we use the white box approach. That means the embedded target procedure. In the earlier session, we went to the example test procedure. Test procedure is organized as per the template, and it will be matching to all the test cases which are relevant to that particular test procedure. And we will refer some of the external documents, internal documents, customer supply documents, etc. Also, we had discussed about the automation testing, PC based application, and manual testing, where we use the debugger. That is, the user has the control to start or stop the program running on the embedded target. Also, we had identified the tools used, the hardware tools and software tools. I will not go through again all this. Maybe I will share all this template and examples so that you have any questions, you can get back to me on this example. Okay, then we had discussed about the setup procedure, how it should be laid out, and to build a program onto the embedded system, how we are going to do it, etc. Also, we came to know that test execution can be done through scripts. The scripts are developed based on the test procedural steps. The test procedural steps can be part of an Excel sheet. The Excel sheet can be used for automating the PC based testing. Then we had discussed about manual testing, which has integrated development environment such as multi or course control studio, etc. Various separate procedural steps for manual testing. This is a typical test environment, how it looks like. So wherein the tools and all that interfaces are driven through the PC, The interface could be any of the interface connected with the target system. Interface could be CAN, Ethernet, USB, etc. And to feed the real time values, we use a breakout box or test panel, which will have all the discretes and logs, etc. Then we had aggregated automated test procedures. Test flow will be written here, and the script what we have done in the earlier stages will be inserted here. Basically, the script can be inserted, or we can refer to the configured scripts here. Similarly, the manual testing procedures, how it should be. This also can be done through the script. As I said, the script also can be developed for an IDE, that integrated development environment, which will have a connection with the debugger. Debugger accepts those commands automated from the script. We can have preconditions for a particular group of tests. Those preconditions are something which has to be mandatorily used before we start the test. It could be setting some values or setting a old capacitance, whatever. So also we have referred an example of automatic test setup, manual test setup, how it will be. And also we can have a test software builder with information inside the embedded software. As I said, the test software is something like a special build which will allow user to monitor or track or get the data from the target. Then we will highlight the tools version, references, any special instructions to plug in the tools. The tool is qualified, those qualified data all will be supplemented here. Then we another section called software download procedure, which will allow us to download the software. So that is about the test procedure example. Okay, so we come to test standards. For us to do all these activities, the test procedure, there has to be a standard against which the test software against which the test procedures are developed. Also, it has other information in the cliffs and guidelines, which will be used for validating or reviewing or analyzing the tests which are done in the test execution phase. So, test standards, it establishes the embedded software system test case design description standards applicable for the system and the test, and specifies if any variants that can be applied. That means if any deviation or if any changes for a specific that needs to be done, all these standards will be highlighted, and it highlights the purpose of the test standards document in terms of methods, tools, or any rules or guidelines that has to be used for test case design and development. So this standards will be frozen during test plan. Means the standards have to be available when we are done with the test plan. It's a software planning or test planning process. So this is used by the tester or the testing team. It identifies the rules, guidelines, and the differences. For example, a rule is response to a safety critical objective of 100% coverage of high-level requirement. That means this rule can be the user or the tester has to cover 100% of the requirement, and there could be some guidelines which will guide the method to develop a test case development and design. High-level test case can have a normal range, robustness, etc. So all this design of the test cases in terms of test inputs, conditions, all this will be part of the test standard. So we will go through an example test standard. How it looks like. Basic template will be same as the test cases, test planning, test procedure. wherein all the stakeholder, the whole chain, and the revisions, configuration items, and all this will be identified. So basically, the standards will have an introduction, like purpose, responsibilities, change control mechanism, compliance will be identified in this section. Next, as we said, we use the XML or when any standard external standard DO internal 260 ISO need to be referred, we will use this mentioned here. So method and rules for design and development of this process. Requirement based process. I have put an example for RBT. This is not requirement based process. So that will identify normal robustness and identification method. Then how to identify scenario, procedure, all this will be probably standard. So we have a guideline system, tool system. How the space should be, like we have seen the template, the same template has to be highlighted or pointed in the last section. Okay, so let's go through a little details of that. So purpose, this document establishes the software test development description standard for the particular embedded target, and the country is going to and who is the customer. For all this information can be here on the purpose, whatever we want to point to, that can be part of the software test case development standard. So this is done at the planning. Responsibility, who will develop or use this. The document is written by the test team and it's reviewed by the assigned project manager, and it will be applied, it will be approved by the test team or the SQL software quality assurance manager. How change control will be used for developing the test. So this document will be updated by the test team in case of changes in the project unit by if there are any changes that need to be incorporated, all that have to be controlled. That controlling information will be part of compliance. You can put any compliance DO standards to sorry, not DO standards, any internal compliance that you want to highlight, something like the same organization. There could be some ISO or some templates or some quality manuals that needs to be tested. The testing has to be in compliance with that, we can highlight it. And as I said, applicable reference documents need to be highlighted. And this will be a separate section in terms of conformance to standard. This standard is going to give the PO conformity for automotive daily. Next comes the rules. We are going to lay out here the rules. Against this, we are going to have a test case design and development. So, one example will be one or two examples. Software high-level test case description shall comply with this document. That means, as per this document pointers, the high-level test cases have to be developed. That means that the rules, guidelines, and templates defined in this document will be followed to develop test cases on this document. And this document talks about rules and guidelines. What are the differences? A rule is a response to safety critical objectives. Guidelines is formalisms and template constitute. All this will be part of the guidelines. But these guidelines will give a pointer to the user or tester in terms of methods and what are the nitty-gritty details about how test data should be developed and all. So it is strictly a guidelines stuff. A rule is a mandatory stop. The verification of the application of rules, guidelines, templates, and permanently mandatory. That means once the test cases or procedures test execution is done, that needs to be verified against this document. That's what the rule says. This itself is a one rule, which is as part of the okay, now coming to methods and rules for design and development of test cases. The aim of high-level test cases description activity is the verification of executable object which complies with the software requirements. Executable object is robust with high-level requirements. That means the executable program or the program that is running on the embedded target should be compliant with the software requirements. It should cater to the SRS, and it should be robust with the high-level requirements, and it should take care of all the robustness in terms of the test environment or the development environment, and the executable object is compatible with the target computer. Okay, so the next one is to verify that the embedded software product satisfies its high-level requirements. The software high-level attestation should achieve the following objectives. That means all the test cases that is developed should cover high-level software requirements. These are all a few examples. This can be tailored or a specific need with updates can be done. The requirements of hardware software interface. As I said yesterday, there should be target can be interface requirements. Those needs to be taken care of. It should be explained or interface to the requirement in the SRS. These are analyzed as interface within the corrective based verification to achieve the hardware software integration. That means if someone wants to do an integration should be against the interface aspects of the SRS. The test cases activity has the following info: SRS, this standard document, and this is the plan. So all this have to be considered as an input for developing the test case. Output of the test case activity is the software test case description document. That is, the test case document itself will be the output of the test case development. Okay. Now coming to normal range test cases. Basically, this section identifies what are the methods that are used for requirement based test cases. There are normal range, there is valid equivalence flags, there is a limit value, there is a table based logic equation, or any special cases, robustness. All this will be highlighted here. This again depends on the target that is being under test. We will go through each one. Normal range test cases will have normal range inputs or the normal range of testing for the testing requirement. As I explained, if a particular requirement allows the user to feed values something like 1 to 10, the normal range is between 1 to 10. Anything between 1 to 10 is called as normal range. So this 1 to 10 is normal range. Next, as I said, there should be an equivalence class that should be analyzed for that specific requirement. So equivalence class will be applied on these inputs. And also there is one point I think very important, that a requirement can take only one input, and based on the condition it could try several outcomes or multiple outcomes. So how are you going to do it? How are you going to modify it? So we need to have consideration of the output also based on the input and other conditions. This is very important basically. So the equivalence class should be applied on both the inputs and the outputs. As I said yesterday, the input could be 1, could be 5, 7, 8, 10, etc. Generally, what they use is the boundary cases for that particular requirement as an input or output. So 1 definitely has to be there, 10 has to be there because these are falling on the boundary. There can be an intermediate value, so that's 5. Similarly, if the output of the requirement is saying 15 and 20, so both needs to be exercised. That means we should write test case in such a way that all the outputs that are derived out of a particular requirement should fall into one of this test case design. Outputs, suppose 15, 20, 25, 3 outputs are there. We should make sure that 15 and 25 are exercised definitely as a normal range, and the mid range as 20, so that we have exercised all this normal as well as equivalence class method. Next, we have a limit values. That means objective of this analysis is to verify the ability of the target system to respond to the inputs taken at the limits of the equivalence class. What it means is that if there is an input of say 1 and the requirement says 1 plus or minus 0.1, that means 10% of that 1 is used, then that needs to be exercised. It means we should have an ability to analyze the requirement in terms of the limit values. That means 1 plus or minus 0.1 means it could be 1 minus 0.1 means how much, something like this, plus or minus 0.1 means that input can take how much, 1 minus 0.1 means 9, and that will take 1.1. So this needs to be used. There are this is useful especially for the analog inputs where we use analog systems which have tolerances, etc. So this is a very important aspect of limit values. So next we have tables. Suppose there are inputs mentioned with the help of a table in a structure, then at least one case should be created for each bounds of the table, and one another will be created for an intermediate point. Similar to that normal table, saying that if the requirement is pointing to a table, table needs to be exercised in terms of either an input or output based on the bounds. That is the lower bound, upper bound, and there should be an intermediate value as well. Okay. Next one is the logic equations. If there are any logical equations, something like usage of or and XOR, etc., we need to use MCDC functional analysis to obtain the different equations. I will tell you what is MCDC in later sessions because this is one of the important aspects of embedded software systems. Modified condition and decision power. I will explain what it is, but that needs to be considered for especially for multiple inputs or multiple inputs and XOR, etc. Then any special cases that needs to be taken here from performance related, timing related, or some requirement could say this product should run at few hertz. Then there is something like time related functions. There will be requirements corresponding to time related functions. Those needs to be taken care as a special performance test cases or special cases of test case development. And that will be state transition also. I will what I do is I will explain one SRS, or I will try to put some minimum SRS for an embedded target system. We will go through probably will understand how SRS is organized. Once you understand the requirement, probably all this can be derived. SRS can have a state transition. We know what is state. It is an event. It's an output as an event moving to different states within the embedded software. Of course, we have a robustness cases as I discussed yesterday. It's be able to feed robustness in terms of, for example, we take one plus 0.1. We should, if the system or the requirement or the embedded target allows us to provide robustness, then we should be able to provide 0.8 or -1. Nothing wrong with this. We can provide. Probably many systems may not allow. In that case, we need to validate manually. I will explain that in the discussion. But definitely users should consider in terms of giving you value. So these are some of the robustness for that particular requirement, which is having an input as 1 plus or minus 1. Okay. Let's go into the next one. Robustness analytics shall be performed only for the external each external robustness values with the value. As I said, this inputs for that particular requirement can be some signal. So that signals should be fed with different values as per the robustness possible. Then we have a requirement test case identification. How should we administer? In this verification level, the embedded target system is considered as a black box. So only that means the high level requirements will be considered as a black box. We will have an external input signal. Scenarios shall specify external input simulation. How I am going to stimulate the external input and external outputs. How I should be able to capture. We can use the power in 2 ports, or we could use any of the registers or any of the measuring systems, measuring the instrument for capturing the output. The next one is first the software test cases development standards. The rules specified for requirement based test cases shall be applied on each of the high level requirement. That means every test case should fall into the standard. So for each requirement, the following elements are different inputs, the inputs of the requirements, conditions, conditions in the requirement, text that causes the requirement test case creation, equivalence class inputs. I think in this format we have found already test cases expected output. So based on this, what are the outputs which will be identified. So all this information should be tagged between 2 tags. As I said, there should be a beginner, there should be and the test case. The next tool is for each functional requirement tested, identification format of the test case should be tested. It should follow the identification format. Each requirement shall be covered by at least 1 test case. The correct one. As I said, every requirement needs to be tested, whatever the way you want to do, in automated way or manual way or analysis way, whatever. For doing that, you need to identify test cases. Definitely, there has to be at least one test case for each of the requirements, and it should be correct one. The next tool is each test case of test case table shall be covered by one scenario and by the correct one. This kind of whatever we spoke on the test table, the boundary values and all that will be identified. For each test case defined, the value of the inputs and outputs of the associated requirements will be identified. If there are any supported requirements, that also needs to be identified. So, typical example for this would be a derived requirement. Derived requirement is something like sometimes what will happen this is talking about the derived requirement or any supportive requirement. What will happen is a primary requirement may not be sufficient to address the functionality. We may need to have a supportive requirement, or it is called as a derived requirement. Something like we have a multiple inputs that needs to be defined in detail. What will happen is the primary requirement we may not be able to define it completely. What we will do is we will first highlight in the primary requirement these are the inputs that we use, and in the supportive or derived requirement we are going to mention that those inputs will take the value of this, value of that, and this will provide this law. Why this derived requirements are needed? Because isolation of the requirement is very important. That means each requirements have to be unique and it cannot be ANDed. That means one requirement cannot have a multiple requirements. That is a brilliant rule that across the industry they follow, especially in the aerospace segment. As one identification or one requirement will address only one requirement. It will not have multiple requirements. If you want to have multiple requirements tagging to that requirement, then you have to identify as a next requirement. That is what is nothing but associated requirement, or if needed, we can have a derived requirement. So that is about this tool. Next tool is for each scenario. That means in this case, and the procedure should be qualified as normal range, or we can add more based on the need. Primarily, these three type of testing is used: normal range, or this I think we have discussed. You know about normal range, you know about so what is that? Some test procedure we may not be able to execute on the car. So we should have an enough scope identifying that as a review, and the procedure test cases will identify how it will be reviewed. Next one is your procedure, how procedures are identified. That is, I think we have gone through the example test here. It's similar to that. So unique ID with the name, parent, which test cases we are identifying, who is responsible, as I said, what type it is, normal, proportional, review, and what is the precondition and ability to satisfy before start of the testing. Inputs, any external inputs that is to be used for testing that particular requirement. Description means how I am going to test it. Means this should be a description para sort of it, or we can add all the steps that is required in terms of practicality. In one of the projects, I think we have used an Excel sheet because it is impossible to specify test procedure 1 step, test procedure 2 step, test procedure 3 step, etc. N. So it is suggested to have instead of this an Excel sheet which will identify all the steps. So it's easier to modify or change rather than updating documents to the code. So it will be easier to interpret. That is what One of the projects it's up to the user depending on the maintainability requirement or how we can maintain. Of course, in the expected results, so we will highlight that proof of coverage for each of the using action output as expected result. And test bench or test setup specification needs to be pointed out here before the procedure ending. And guidelines. Let's say these are all rules. Rules have to be followed mandatory. Guidelines are based on the need. Some requirements may need one guideline, other requirement may need other guidelines, etc. So guidelines are differentiated. So something like a general guidelines for developing guidelines. So an example, description of the scenario should be clear and accurate. The expected result should be different for each scenario. Each scenario should have an outcome. It should result in an expected outcome. The setup specification should be different for each scenario. As I said, each scenario will have to be identifying the setup, how I'm going to execute. Preconditions should be specified. These are the guidelines. Some of the requirements may not have preconditions. Directly we can execute based on the preconditions of the previous or by itself it may not be preconditions. In that case, they may have none. So let's say it's called as a guideline. And in the end, we are going to specify the tools used to produce the test case development. Usually it will be a document, Microsoft Word or Excel sheet, whatever. Or if there is any tool used, Cantata or any testing tool, we can highlight it. So what is the language used for producing the test case? Test case document template. So in test case example we have gone through already. It's a repetition of the same. Yeah. So test case should be identified, covering each of the requirement. Scenario should be defined. The appendix list out all the test cases and scenario specifically highlighted. This is also part of the test case. As I said, static analysis group of test cases, manual group of test cases, all that will be part of the coverage. How I have organized the document. So that is about the test case standard. So now, up till now, we have gone through test case example. Of course, we started with the test plan, test case, test specification, test procedural document, and testing standard. So with the help of that, I should be able to design test case. So simple example I had to developing the test case. So you all know whiteboard, right? When you are writing using the pen, we use the whiteboard. So whiteboard requirements, I have put 4 requirements. So what will be the sample test case? What the whiteboard requirement? So requirements are something like whiteboard shall have a length of 3 feet by 4 feet. Whiteboard shall allow to write on it. Whiteboard shall allow to erase the written words. Whiteboard shall allow to write colors like black, blue, green, and red. That is why it is called as whiteboard. So, 4 requirements. For this, what are the test cases? The few test cases which I have identified. Measure the whiteboard and verify that the length and width of the board is 3 feet and 4 feet respectively. So this will cover first requirement. Next test case could be check whether one can be able to write on the board. That is the next test case. Because we should allow us to write. So that is why we have written a test case. The next requirement we have tested with check whether one can able to write black color on the board. You can use verify instead of check. So that will be a better word. Usually we use verify. In this case, what we can do is verify that measure. Okay, already we have a verify statement. So measure the whiteboard and verify that. So next test case is on. Check whether the written words in black and green or is it. It means there is a difference. You should be able to write. That is the first thing. Next thing will be you should be visible. So both are very important. And also, I think you can add to me something like that. Verify whether one can write. What is the supplement to this picture? So we have specified here black, so you can specify blue color. Similarly, we can be able to write green. So and of course, as I said, you can have a combination of both. Both should be allowed, right? Verify whether. I am taking a simple example. We can analyze this in terms of a software requirement or a system requirement on the embedded package. Verify whether one can write blue and green both. Next could be check whether or verify whether one can visualize blue and green letters. Could be letters, words. Actually, this is not a good practice to have or something like letters or words. Or better you can mention as another case, highlighting just words. So just as an example. Next case is check whether the written in the black is visible. Try to erase the words. This is the interesting thing because the requirement has not told, but this is by intuition. You can have a generalized requirement because we know that whiteboard we are testing this. So this case is interesting because of that. Try to erase the words written and write a new words. Verify that the words are erased. New words are erased. I think we have erase is there. Okay. Good that we have all the requirements. Sometimes what will happen is by intuition, user may add more requirements because he has a good knowledge on his system. His system is whiteboard. So during the review, what will happen is this will result in modifying the requirement. I have seen that, or this will result in adding further requirement. So in that way, as I mentioned yesterday, the testing team or the tester should be independent. So he can think out of the box, he can think from his perspective. So that is always suggested. Okay, so this is example testing. Any doubts or anything is there on this, you can ask me. Okay, let's come to having gone through all these test case standards, test procedures, test specification plan. I have put question, simple question in that side. Maybe we can do this and we can touch with the answers that we have written out. Why we need test plan and what are the elements that it identifies? So simple question. Write test strategy for the below set of requirements. You know what is a test strategy by now, and you should write test strategy for testing the below requirement. Below requirement is attached here. An embedded unit instrument. I just put an example. UI product. The software requirements are as per. So we should have a test strategy how it is. I will further go to the next question, and together we can see into this example. The SRS has modes of operation on set of requirements. So the next question is write the test cases. Modes of operation. There are different operational requirements. I think for now you can write test cases for that modes of operation. we can see how good we are. And we can write test cases with a specified test format, which should be right. And as I said, you can use an Excel sheet to write it. Excel sheet can be something like this. This is of course an example for a test case scenario or procedural example. We can enter test step 1, 2, 3, 4. Test step name. Just highlight what I'm going to do. So in the description, I'm going to tell that set all the inputs as mentioned in the precondition section. So preconditions means it will be pointing to a section which will specify the conditions that are required for executing this particular test. So after that, we are going to power on the unit. Then we will set the status or error depending on the set status to error, because we want to test something on the nodes of operation where it's going to go, etc. This is just a template. We can write using that template. I will share PPT examples. Based on that, we can do. Question is basically based on the requirement. Write the test strategy. First, we need to write the strategy. How I am going to address the complete requirement. We need to understand the complete requirement. But once you understood the SRS, there is one section called modes of operation. You need to write test cases, and you can use the template. That's for this. So this is the Excel. You will open the SRS. So you can go through this. You will have an understanding. Basically, SRS will have a system overview. I had to put myself simplest requirement. It's called embedded delivery system. So the overview of this embedded delivery system is as the below functionalities: initialization, maintenance, and maintenance management. Then we have a monitoring function, which is also called as built-in test management. There is a failure management. There is a fail mode. So this will have all the failures detected. Any actions that are required as a result of failure, that also is part of this failure mode. Then we have a download mode management. I told you earlier that software, embedded software needs to be downloaded onto the target. So the software should have a program. I mean, the software should have a function which will accept this downloadable program. Usually, the embedded system target will have two sets of subsystems. One is a boot loader, other one is an application. So usually there will be changes in the application. So boot software plus loader is called boot loader. This is responsible for downloading the new program. The new program could be new program or image. Some systems will have programmable bootloader also. Suppose you want to upload or download new loader itself. So what we will do, we will have this boot software. So that is having this download mode management, which is responsible for loading the new loader. So basically, download management is a set of functions which are part of bootloader, and some functions part of that also is part of application. Next one is script form. So So this custom I will not go into the detail what is this custom and device it's part that is used in embedded system. It is strictly readable programmable memory. We don't need to. From the external world, this can be accessed to fetch any of the data, or if the user wants to program new configuration of calibration, with each person will be used. Basically, use a separate device as part of the embedded system. There is a, as I said, there is a fault or failure that needs to be stored. When the system is off, there should be a memory which identifies the failures or the failure remains. That will all part of the fixed form. Then these are typical embedded applications unit control. This embedded unit has a control function which will drive and calculate the PWM. PWM is the details probably I will not go because that is not the scope of this. You can Google and get an information about this. This requirement or this functionality is talking about how you can drive the target. While driving, we have different functionalities: voltage control, current control. Then we have a specific motor control, MTR, PTR. So we will also drive and control modulation with the calculation. So there is a motor startup, there is a motor speed, there is a motor current. So I try to put the simplest of requirements. There are further complexity involved. So let's not touch this. We just highlight the basic requirements of the functionalities of a typical embedded system. There is an actuation mechanism, CAN actuation, which is used for communication. The data, the external interface or the inputs or the outputs, how it is going to be communicated with the embedded target. So that is with the help of CAN. The same thing is highlighted here. The embedded unit is the core of the motor control unit and will implement the following main motor drive control and monitoring, unlock the digital conversion, failures and data transmission to outside world like Canada, failure storage in the memory, and any maintenance that is required will be done through CAN. Software loading, download management is done with the help of CAN communication. And there are of course few LEDs with the help of IO lines that will be interface. An external expert form will be used as a service. UI will interface with the expert form by means of SPL. So let's not discuss about the interface. I think that is I'll make what is the interface. So there are different things that is involved in the software requirement. We should identify operational requirements. We will identify record initialization. We should identify download, etc. Accordingly, you can see the section. Operational requirements. These are the operational requirements that embedded should have. There is a small depiction of the different modes of operations. So there is a unit mode, there is a operational mode, there is a maintenance mode, download, and upon failure it will come into failure mode. So these are some of the overview of operational requirements. Then we confuse with operational requirements with the operation. This operation is not a mode. I hope it's clear. Okay, coming to the modes of operations. What are the modes that embedded instrument of? So these are the requirements. You can go to one by one. Maybe I can explain in this session. Anyway, you can go through and you can set this possible. So what are the requirements for different modes? Unique mode is there, operational mode is there, message mode is there. Then we have failure, download, etc. So all this covering as part of the embedded target which we are done to develop test cases. So there are timing requirements, there are performance requirements, there are communication requirements, everything we can. We will have these requirements. So the partitioning requirements will be there. So again, these are the none. There is no separate different applications involved in this embedded target. One single application is done. Some industries they call boot as well as application of two parties. It's not delve into that. It's very simple application. So different states so that embedded will be implemented in level. So what are those states? What are the motor states? What are the memory states? Those are the state level, state of a state requirement. Then we have functionality. Again, look how it's going to do. Initialization is there, built-in test is there, reset is there, etc. Similarly, we have fault management, download management, interface management, and there is a section in the end, tolerances and constants. As I said, some of the unlocks and discretes will have tolerances that needs to be primary. This is used across the whole requirement document. So what you need to do is there is a modes of operation what we saw just now. You need to write test case. That is here. These are the modes of operation. There are 1, 2, 3, 4, 5 modes of operations are there. Init operation, maintenance, download, and set. So the embedded instrument should be in one of these instruments when it is powered. One of these mode actually. Upon power up, it will be in the initialization. Then the initialization is fine and true. Then it will go for operational. When there is any maintenance is required, it will go for maintenance mode. And when there is a new software or the download is required, it will go for download mode. Similarly, if there are any failures while doing operational or maintenance or download, it will go for a failure mode. Same thing is depicted. You can see there is a small note for each of the arrow. So that is nothing but a transition. So how it will go to the next step from maintenance to operational. So the mode should be operational. It will become here. The mode is something like a state. It is updated by the embedded software based on where it is. Below are some of the requirements. I will not explain detail in both. There are about 5 requirements. Most of the questions you can type. You can compare this or that is about test case design, test procedure, and standards. Also, we have discussed about test plan. So we have few examples. Once we are clear about this, we can go to the next section.